Welcome back, everybody. I hope you had a chance to network and meet some of our sponsors at the booth. Next up is Laurent Gil talking to us about cloud neutrality.
Yeah, one thing that I wanted to say about Laurent, a lesser known fact about him that he just shared with us. Apparently, Laurent is one of the few French people who doesn't like wine. But to be fair, it goes to show that you don't need alcohol to be fun. Welcome, Laurent. How are you doing?
I'm doing good. I was trying to put this hat on, but it's not really working. So I can put it here, but
at least the bow tie is staying.
So not ideal thing. So, guys, very nice to meet you. It's a pleasure to speak to all you guys. I'm going to speak about a subject that is very dear to me, which is cloud neutrality. It's actually the reason why I started the company, my company, Cast AI. We think that thanks to Kubernetes, there is a way to end the cloud monopolies. So let's see if that works. I'll show you a real demo of how we do this. If the demo gods are with us, they are not always, but sometimes they do. And yeah, I'll show you a real demo of how you use Kubernetes to destroy this evil cloud monopoly of our dear friends at the cloud providers. So let's go. I'm one of the founder of Cast AI. That's great. Let's do it. So cloud neutrality. Why? Why is this so important? We all remember a few years ago, or some of us at least remember a few years ago, internet neutrality was everywhere. And the idea of internet neutrality was, hey, regardless of how much I pay the internet, or regardless of where I am located, or regardless of who am I should be able to access the internet the same way as my neighbors and everybody else. Now, it's pretty much done in many of our countries, not all of them. Hi, China. But otherwise, cloud neutrality is pretty well accepted. Internet neutrality is pretty well accepted and quite a success in many ways. Cloud neutrality, though, is not. And I think it's the big forgotten industry where there's absolutely no neutrality about it. And here's why. It's in the hands of multi-billion-dollar privately owned infrastructure companies that are essential now for the modern internet economy. The point is not that it's privately owned. That's great that it's privately owned and it's great for business. It's the non-regulated that bothers me a little bit. It's the fact that these guys have a lot of power to do whatever they want, whenever they want it. So, in my opinion, that should freak you out. It's actually not my phrase. I took it from Mollywood. She wrote a very nice article in Wired last year about this. But it freaks me out that there is no regulation on cloud neutrality. And I'll explain to you a little bit of why. So, number one, the cloud is a fortress, and you host your business in that fortress. The fortress is good. It prevents the bad guys to come in. So it prevents the hackers. Cloud have great services that filters some bad traffic. They have application security. They have identity, very great services that make the cloud a fortress. And it's a great idea to host your business in a place that is extremely secure. Problem is there are only 3.5 of them. And I say 3.5 because that means the usual 3 with AWS, Google, Azure, and Amazon. Amazon, Azure, and Google. Yes, that's 3. The 0.5 is the rest of the world. So the Oracle, IBM, DigitalOcean, Linode, and then if you are in certain places, that would be AliCloud and a few others. So there are only 3.5 of them. And so you see the problem now. It's unregulated. It's in the hand of very few corporations. And by the way, the landlords may deny their protection. That's very controversial. You probably remember it was only in January it happened in the US where one application was kicked out from AWS. Now, you may agree or disagree with the movement there. The point is AWS had the entire power to make that decision based on how it pleases them to kick out that application. The application was called Parlay. Apple, of course, did the same, Twitter and Facebook also. The point is you have no control of how these cloud providers may act on your business. I mean, think of this as if you're a grocery store and you're extremely high success online, and yeah, you probably use Amazon, and then suddenly Amazon knows a little bit more about you. They know how many machines you use. They know how much traffic you have, how great you become, and that's information that may go into a competitor. It's very hard for this to happen. They have great Chinese wall, but the walls are Chinese anyway. So the landlord may deny their protection, and it's not like you can move quickly to another fortress. That's the other problem of cloud neutrality is when once you are inside AWS, then that's it, you're there, and good luck to move away from them. Using traditional techniques, that's going to be very hard. And by the way, they make it very hard for you to do that. So hence we live in this world where control of the market for cloud services is consolidating under a handful of tech giants, and these are the tech giants. Those are the tech giants that have enough money to blanket the globe with data center. We are all guilty to this as well. Like, why do we choose AWS? Because they are everywhere. So the more everywhere they are, the more powerful they are. Therefore, the more we want to be with them. And so you kind of see why cloud neutrality becomes an issue now, and the non-regulated side of it becomes more of an issue in that case. There are other things that happen on the cloud, and that's called the outage. Remember, you're on AWS. AWS went down in November 25th last year. I still remember this. In 2020, and all U.S. Eastern Seaboard AWS regions were down, we were down also. So that also should, that's outage in 2020. That also should freak you out. The fact that there are few players, it's very hard to move away from them. They make it very hard to move away from them, and if they can kick you out, and it's very hard to go somewhere else. And maybe they have an outage, and that's good luck. You sync with them. If they ship, you think you sync. So the cloud is not built for vendor neutrality, and I almost want to say it's by design. So we did this study before we started the company. So it's a year ago. So these numbers are a little bit old, but I just refreshed the price this morning. So when you use a hot commodity, compute is a hot commodity. It should be a commodity. After all, compute is just made of CPU and memory and a bunch of other things that sometimes are more specialized, but most of us use the exact same things. We have a choice between Intel, AMD, and maybe ARM, but otherwise these machines are very, very similar. So when they are very similar, you feel they have the same price. They should have the same price because it's supposed to be a commodity. So we did that study. We went and benchmarked 500 different instances in 84 places all over the world. This is the first thing we did when we started Cast AI. And so what I just show you an example of a 4-core machine. The Oracle one has a bit more memory. The Google Cloud one is 16 gig. Very standard type of machine. I think it's probably one of the most popular machine on the cloud, the 4-core plus memory. Kind of similar price, you can tell. I mean, one is 10% higher, but that's because they have more memory than Google. But the thing is, look at that. The performance of these machines are very different. And we measure that. We run an application. We measured how much compute quantity we have if we use 100% of the CPU in these two servers, these two VMs. And the one from Oracle give you almost twice the amount of compute compared to the one from Google. So granted, Oracle is 10% more expensive, but it gives you a lot more compute compared to the other one. That should not happen. That's wrong. That is telling us that the price is inefficient. Why is it inefficient? We're not the only one that discovered this. If you are Oracle, you probably want to claim this very loudly. But if you are Google, you're probably thinking, oh, maybe I'm not pricing this very well compared to my peers. And if I continue to do this, I'm going to lose business. It doesn't happen because of the fact that it's very hard to move from Google to Oracle. It's very hard to move from one cloud to the other. These guys know that, and that's why they make it very hard to do. So whenever we do this kind of benchmark, it's kind of opening our eyes. It said, well, there is a lot of price difference of something that should be a commodity. And apparently it's not. And it's very hard for you to use one over the other. It's very hard for you to choose one over the other. So what can we do about it? The first thing we thought was, well, maybe there are some regulations we can put. It would take time. It worked for somewhat for the internet. I think it will take time. There are other things we can do, and that's the reason why I'm here. There is hope. The first hope is Kubernetes. Kubernetes was designed at the beginning, and the true reason of Kubernetes was, hey, I have some containers. They run independently from each other. They kind of run independently from where they are. And theoretically, a container can be deployed in any machines, in any place. It will work without changing a line of code. That was the reason why we all love Kubernetes so much. Of course, the cloud providers did their own version of it, including Google, who is in the inventor kind of Kubernetes. And every time you use their Kubernetes as a service, you are stuck. Yeah, it's supposed to run everywhere. But if you use EKS, it will run only on Amazon. If you use GKE, it will be only on Google. If you use EKS, it will be only on Azure. However, there is still hope because the principle of Kubernetes was that thing that says containers can run in many, many different places. I'm going to show you an example on how we deploy Kubernetes application across multiple cloud, and it just works. That's why we think there is hope. Now, there are not that many players that can do this, but I will show you in a very simple way how you guys can. The other reason why there is hope is this. I'll show it to you because it's also something we checked, and that was, maybe it's not working. That was very telling when when I started the company. And the realization is, I'm sharing some screen. This is a Google book. It's actually a data science work that we did. Here, I'm going to show you in a minute what this means, if I can make it bigger here. So what we did is there a way that we can deploy an application, let's say in Frankfurt, and this application should only have a choice of cloud providers? And this is how we did. We analyzed the latency here. We analyzed the latency between cloud providers in one region. We did this for 84 regions, and 500 machines in this. So it's pinging all to all and see how far are you from a millisecond from each other. And that was telling. See, this says, well, the Amazon region in Frankfurt is actually 1.7 millisecond away from Oracle, 1.8 millisecond away from Google, 2.1 millisecond away from Azure. And then, of course, you have Switzerland, Amsterdam, that are not too far away. What this means is the realization that, yes, there are some clusters of cloud providers that, in fact, are so close to each other that you could eventually think of a deployment of an application in one place, let's say Frankfurt, where suddenly you could theoretically use VMs in these places. You could use one VM on Google, one VM on Azure, one VM on AWS for the same cluster. The cluster is made of nodes, so we call this VM node. And if you can make them sit on the same network, they don't even know that they are on different cloud providers. And that's what we did. And that's the demo I'm going to show you. And these are all the clusters. It's a realization that all these cloud providers think the same. And in this case, it helps us. They think the same, meaning if they want to be in Brazil, they are all in Sao Paulo. If they want to be in Australia, they are all in Sydney and a little bit in Melbourne. If you are in Japan, they're all in Tokyo. All means the 4 top cloud providers, Google, Azure, AWS, Oracle, are all in Japan. In Tokyo, it's in Shimbashi, and it's across the street. I've been there. The same in Mumbai, in India. These places are, Sydney in particular, are famous for bad pricing, extremely expensive internet. Well, guess what? All the cloud providers are there, and you can create a network between them, and the network is 1 to 2 milliseconds away from each other. And that tells us in the Kubernetes world that, yes, we could probably stretch a cluster across all these places. So nothing prevents a cluster to stretch across more than one cloud provider because you can connect them with a network. I personally really like WireGuard VPN, so the network connection is completely encrypted. That's what we use. And I am going to show it to you right now. So here is, I have to show you a little bit of our product, but think of this as more, I'm deploying an app. This app is living across more than one location, and let's see if it works. So I created a cluster this morning. The cluster is on AWS and, let's go. I created it in AWS and Google. It means I created the network between these two things. Dormant state, nothing is deployed. I only have two nodes. One is the master node, the other one is a worker node. Because I just need one worker node, there's no reason to have it in more than one place. That's exactly what these things did. If I want to look at the nodes themselves, I really like this visualization. Every green box is a pod. This is the master node, and this is the worker node. Everything goes fine. There's no app deployed here. I'm using AWS, everything is cool. Now I'm going to deploy an app. I'm going to deploy this one here. Let me just make sure I'm in the right place. Yes, so Kube, CPL, apply, F, and I'll do all. So I am deploying an app right now in this cluster called multi-cloud. The app is being deployed. If you see here, you see all the pods that are trying to be installed. Some of them goes into this node. Everything so far is cool. They are yellow. They will become green when they're installed. I have a bunch of unscheduled ones. That's our life in the Kubernetes world. So I have unscheduled pods, of course, because I just deployed an app on a worker node that is not very large for it. What should happen now, if the demo god are with me, and if I did this well, what should happen is I should add a few more nodes, and I have cluster autoscaler that is turned on. Therefore, nodes should start to appear. It will take about 2 minutes to appear. That's typically the time it takes for cloud providers to do this. Now, I did not specify where to put them. This is kind of the good luck thing, is my engine is thinking, hey, I need some new machines. Can you please find a way to put them? And here it is. I just refreshed the screen, and you can see this is real time, right? This is not a CAN demo. It's happening right now, thanks to the demo god. But you can see there is a new, there are 2 new machines. They're actually on Google this time. They are E2 standard 8. Oh, there's one E2 standard 8 and one E2 standard 4. And they are pending. Pending means it takes about 2 minutes for Google to provision a VM. They already sit on the same network. That's what I did with WireGuard before. My cluster is a logical cluster that knows where to find VMs. Is making the decision based on pricing in this case, because I can. The great thing with multi-cloud is you have the price list of AWS to play with, but now you also have the price list of Google to play with, and probably the engine said, yeah, it may be cheaper to use preemptible on Google over using preemptible or spot instance on Amazon, which is probably what happened there. No, it's not always like this, right? Sometimes it's Amazon who wins and it's Google who is more expensive. This is spot instance versus preemptible. It's preemptible because I told the system to do it like this. I told him, hey, if these are stateless pod, why don't you use a cheap discounted instance? Exactly what's happening now. If I go here, yeah, these are, they are still, these machines are still waiting to be created. So you hopefully will see them here once they are up and running. And as I said, it would take about 2 minutes to do this. Let's just wait a little bit, because it would be great to have these machines there so you guys can see how these things will go. By the way, one other thing which is great with Kubernetes is you can tell this CPU is going to the roof. I am really, I am really optimizing here as much as I can. I mean, the automatic cluster autoscaler is doing this for me, selecting a great discounted VM. It's not very difficult, right? You just have 2 price lists and you just search the cheapest one of the 2. And because it can go on spot or preemptible, that's the price list it's using. And you can see now you start to have the app being installed in this is one of the Google VM, and then as soon as this guy is ready, you'll probably hopefully have all this yellow thingy go here, and that will be the end of the deployment of my application. So again, I did nothing here. I just created a network between cloud provider. I did it automatically, but you can use WireGuard. It's very easy and simple to do. Created a network between 2 cloud providers in one region. Let me see which one I selected. I selected US East. I created this maybe an hour ago this morning, this cluster. My cluster have now 3 worker nodes, 2 of them being on Google just because, and 1 being on AWS. And my app is almost finished to install. This is the app, so I'm not sure it will work because there are still some pods that are there, but a lot of these pods are duplicates. So this is the app. I'm refreshing. Yeah, the app work. For some of you guys may know this app. It's open source Google e-commerce application. It's actually the one that Google used to demonstrate Anthos. I really like it because it's very clean. So let's go. This is an e-commerce app. And say, oh, I like this typewriter. I'm going to add it to my shopping cart. Then I'm going back to my main screen and say, I like this record player. Great. I'm going to add it also in my shopping cart. You notice that my shopping cart says 2, and my shopping cart is persistent. Yeah, the fact that I live into 2 cloud providers, they are 1.5, 1.7 milliseconds from each other, or 2 milliseconds from each other is great. My data is persistent. One of the pod has a Redis, which is the one that captures this shopping cart. And everything works. I don't need to do anything. Now, what you guys see here is probably the most resilient, or one of the most resilient e-commerce app in the planet. Why? Well, if AWS goes down, let's say if Google goes down, because I only have one masternode. So if Google goes down, this app would work. What this means is the engine will say, oh, I'm missing 2 nodes. Great, I'm going to create 2 new nodes. Oh, I don't get response from Google. Great, I'm doing this in the other place I can, which is AWS. So you see, there are some interesting advantages for cloud neutrality. One is the obvious one, which is optimization for resource. Here you can tell I had to add 2 nodes. I use pod instance, and it selected Google. Let's see why in a minute, but it selected Google, I assume because of the price. And then it's resilient. If these 2 things disappear, by the way, they're designed to disappear as pod instance, a preemptible instance. If they disappear, I'm fine. It would just, the auto scaler would just say, oh, I need to create new nodes. And where do I do this? Well, in the place that remains. That would be AWS in this case. So that's kind of how this thing works. Of course, it's a simple case. It's ideal. It's an app that is well done. You can deploy it easily. These 2 cloud providers are friendly to each other, so they're not too far away. They're the same, not the same building, but not far away from each other. All of these things works here, which is nice. But the principle is, yes, it works. It works by design, and it works despite some of these guys, in my opinion. Let's just see why I did this. So I'm curious. So I have a E2 standard 4 and E2 standard 8, and I opened this pricing for Google in advance because I wanted to know why it selected this. So, oops, if I go back to here, say, so there is an E2 standard 4, E2 standard 4. It's a 4 core, 16 gig of RAM. Oh, this is the preemptible price. So I have a highly discounted one, 0.04. And then if I go to the same on Amazon, oops, let me get this. So if it's a 4 core, it's this guy here. T3 X large. And yep, the Amazon one is a little bit more expensive. This is the price right now. So at another time it may change. But yeah, right now it's 0.499. So let's say 0.05 over Google, which is 0.04. And so it's 0.005 price difference. And if you think about this over 0.04, it's like 20% or 25%. So that starts to be now a great business proposition that says, yep, if I use Kubernetes, if I'm true to Kubernetes, I don't use the Kubernetes as a service of the cloud providers. I use the open source version. Guys, this is the open source version of Kubernetes. I changed nothing to this. It's 1.19.7. You can use COPS if you want to. You can use any way to do this as your favorite tool. You create a network between 2 cloud providers, and you deploy your app. You have a smart autoscaler that selects the best machine, but you have many of these, and select the best machine means the best price. That's not very hard because all of these are API, and then you have price lists for all these things you can retrieve over an API. Then you get this situation where, yep, I am more resilient to an outage. I'm fully independent to a cloud provider. I can, if I had made my masternode high availability, so if I had 3 versions of the masternode, I probably would have put one on Google by default and one on Amazon, and everything would work. By the way, I can do this with 3 cloud providers. I can do this with 4 cloud providers. I can do this with as many cloud providers as I want. The only constraint is they must be fairly close by, so that you don't break anything because of network latency. There is one thing, though, I want to say, which goes against it, which is since you are connecting Google and AWS for the same application here, you have somewhat unpredictable transit. when you're on only one cloud provider, transit between nodes is free because it's AWS to AWS, the same region, the same availability zone. But in the case here, you are paying for transit between Google and AWS. So you pay for transit, but you also get some optimization on cost optimization. So it's a trade-off, it's a balance. Depends if your goal is disaster recovery, then this is no-brainer. This is in my opinion, much more elegant compared to cluster federation. So cluster federation, you actually duplicate the app twice. Here, I don't duplicate anything. It's just one app that happened to use 3 worker nodes that happen to have 2 of these owned by Google and 1 owned by AWS. Now think of this as, I just made compute a commodity. I treat a Google CPU and memory the same way as I treat an AWS CPU and memory. I do not care much where they are, who they are owned by, whether it's Mr. Bezos or the Google guys. And I select the one that I like the most based on, in this case, a policy. The policy is great to use cost, but the disaster recovery would be one that is as valuable as that, in my opinion. And I don't duplicate this app twice. I don't duplicate it once on AWS and once on Google. The consequence of this is, yes, you can make compute a commodity. Yes, you can move from one cloud to another. Yes, it doesn't matter anymore which cloud you use, if you think about it. If you add DigitalOcean to that, DigitalOcean is famous for being a little bit cheaper than the others. What do you see? Well, you see a blacknet where a lot of the high-end or high CPU requirement pod will naturally move around and probably go into a DigitalOcean over the others. But if you can use Spot Instance, then you're playing now with super highly discounted AWS, Azure, and Google highly discounted machine, and you can play the competition this way. You can tell Mr. Bezos, yep, I'm only using AWS when I feel like it, and when I don't feel like it, so meaning when you guys are too expensive, I'm moving away. And I do this in real time, and I do this all the time. So that's what I wanted to show you guys. Just to show you quickly that the network works. So I'm using Cilium, also open source for this, and I'm going to ping latency between these. So you see how bad or great latency is. And of course, I forgot it's this Cilium health status. So if you look at this, so between the same cloud, of course, it's less than a millisecond, but between 2 cloud provider, so this is probably the ping between Google and AWS, I am 2.23 milliseconds away. This is by using the internet in US East. This is why it's possible. That's what it's great. And believe me, I did this all over the world, and we get the same type of result. In some countries, it's even better because, like Tokyo, they're across the street, they all use Equinix. In US East, these are separate, huge data center, but 2 milliseconds for me, or let's say under 5 milliseconds for me is okay. Whenever you use Kubernetes and your application is made of pods, they are designed to handle this kind of distance between them. So that's why there is hope to use multi-cloud to achieve cloud neutrality. Don't wait for the regulation, even though it would be great if there is regulated for cloud providers. But you can go and tell your friends at Amazon, Google, and Azure that if you don't like them, you can go. And you can go because it's cheaper over there. So thank you, guys. If you have any questions, great. We have 1 more minute. Otherwise, you feel free to send me an email. My email is here. It's Laurent at cast.ai. I'd be super happy to talk to you guys, show you how this works, and discuss about cloud neutrality whenever you have questions. So back to you,
Laurent. That was a great talk. I'm loving the graphics, like the 90s video game UI thing. That was amazing. Domi, do we have any questions? I think we have time for one question live.
Yeah, I think we had a few questions, so we can see how far we get. So one of the first questions that I saw pop in was what are the costs related to data transfer? How do you prevent from paying the value for network out to internet that cloud providers usually charges?
Yeah, it's a great question. So the idea is we typically use an AI engine that will factor in the additional cost of transit versus the reduction of cost of compute. And so whenever your reduction of compute is higher than your additional transit, then you'll do that. Otherwise, you stay in one cloud provider. I call transit cost the transaction cost. If you think of a stock market and compute is the stock you want to buy, the transaction cost of buying this is your transit. I hope these cloud providers will reduce their transit, its charges. They have like an 80 times margin on it, especially AWS. Yep.
All right. Another question is, how do you position your solution versus others like Red Hat OpenShift, which is also positioned for multi-cloud deployment?
Yeah. It's all good. The more we are, the better we become. Let's destroy this and make compute a commodity, and the world would be better. Every time, like remember, Ford made the car in the 1900s, and he said you can have any color you want except if it's black. But now the car was a very luxury item. And suddenly in the 1900s, it became a popular thing that you and I could buy. Let's do the same for compute.
Cool. Thanks. And then one last question from Tibor. He was saying, since this is adversarial to cloud providers' efforts to encourage vendor lock-in, how would you avoid creating a similar arms race as with ad blockers?
Let's do it. Let's see what happens. That would be my only... there's no penalty for trying, and I think it's such a hot resource that whenever you see a resource become democratized or commoditized, you'll have more people use it, not less people. So I think that's it's the direction of history. Right? We've seen this in the human history all over again.
Great.
Let's do it.
Thanks again for your talk. If anybody else has questions, feel free to ask in Brella, and Laurent can then answer them there as well, or as he said, via email. And for everything else, we are now 5 minutes away from the panel. You can head over to track 1 for that.